Hello. So in this video we're going to be looking at a different kind of function. This function's a bit weird. So we're going to have some function here, but something's suddenly going to happen around here. Whoa, what's that? So you'll notice that this function has a bit of an issue. This function, it doesn't continue into itself. You'll think, well, yes, it's not continuous because it doesn't continue from one arrow to the next arrow, and you'd be right. This is actually this is not continuous. This is a discontinuous function, but it's a different kind of discontinuity than what we've discussed in the previous videos. So this kind of discontinuity is called a jump discontinuity. A jump discontinuity. So a jump discontinuity is when the function is going kind of in one direction, or it's approaching this value up here, but then it suddenly just shifts all the way down. You can imagine it travels along kind of an undefined line downward, like a vertical line downward, and then it continues down there. But if you were just kind of like walking along the side of the line, imagine if there's just suddenly a cliff. You wouldn't be able to predict that, and that's all that, as we saw in the last video, that's kind of what continuity is about. Continuity is about the limits of the function as you get closer and closer to something, having that one defined value. But here you don't really know. If you're down here, you think, oh, whoa, I'm suddenly getting off into nothingness, and over here you think you're getting up to this top of this hill. So this is this is discontinuous because our limit is not a single value. We can't say the limit. Let's say this is our point C again. If we say the limit, I'm going to write in cursive this time because it's nice, as x goes to c of f of x, we're going to say this is some function f of x. This is some function f of x. We have our x and our y is equal to f of x axes. When we talk about the limit as x goes to c, there are two values here. Look, there's one missing down here, and there's one here, but it's up here. But so there are two values we have. Let's say we have this one value. This is going to be called y2, and this is going to be called y1. We can't say that there's one limit because there are these two limits. If you're going in this direction and you're getting closer and closer on this side, you will get to this value down here, y1. That will be your limit. That's what you're approaching. But if you're up here going to the right, you're getting to this value, y2. So what we have to use for this is the notion of a one-sided limit. A one-sided limit specifies kind of the direction that you're approaching in your x-axis. So we're going to define this as two separate things. We're going to say the limit, we're just going to write it like this, of f of x as x goes to c, but now we're going to do something else. We're going to put a little plus sign up here, as if kind of it was an exponent. So as x goes to c, positive of f of x, and we're going to have the limit as x goes to c, negative of f of x. And these positives and negatives just specify kind of the direction that we're traveling in, because you'll see as we get closer and closer, if we're coming from the right, if we're coming from past this this discontinuous spot, we're getting closer and closer to this point down here, whereas up here we're getting closer and closer to this point up here if we're going from this side. So there are two different values, and the x goes to c positive means we're coming from the positive direction. So we're going negative. So we're up here, we're in the more positive direction, we're coming from x points that are above c, and the negative one is coming from x values below c. So this is x goes to c negative, and this is x goes to c positive. And let's try and define these. So this, we can't define this. This is undefined. There's not a limit that exists here. We cannot say the limit as x goes to c, because that's just wrong. You say which limit, right? But we can talk about the one here. So the limit as x goes to c positive, well, it's getting closer and closer to this one value here. And I know that the definition of limits I've given so far is not necessarily formal, but I think it really helps to get the idea across. So we're getting closer and closer to y1 here. Whereas on the other one, we're getting closer and closer to y2. And this is a two-sided limit because, I mean, we could have the green spot down here and then have the circle up here. That's kind of messed up. Here. Have the circle up here, and we get the same idea. It's just, if we just plug in c, the idea is that we get only one of these values. If we, f of c here is now equal to y1, but not y2, even though the limit approaches there from our function from the left. So this is just meant to kind of introduce the idea of another kind of discontinuity and how you can deal with limits when you have to break them down like this. I hope you had a lot of fun. Thanks for watching.